Welcome back to Math Solver 1117. If you are the kind of a person who loves solving brain twisting problems, then this video is made just for you. Today we are going to solve a real problem from the International Mathematical Olympiad 2024. One that left even the brightest students dumb. But don't worry, I will guide you step by step, and at the end of this video, you will not only understand the solution, you will feel confident to face IMO 2025 like a champion. Now we will start the solution of this problem. First of all, we are given an infinite sequence of positive integers, that is a1, a2, a3 up to so on, and a positive integer n and a positive integer capital N, such that for small n, that is greater than capital N, is equal to the number of times so an is equal to the number of times an minus 1 is appear in the list of numbers that are a1, a2, a3 up to an minus 1. So this is the proper definition of the sequence property. After this, we will check the behavior of an for large value of n. So for large value of small n, because we say that small n is greater than capital N. So for large value of n, we will say that consider the sequence of values. Capital N is small, so an plus 1, an plus 2 up to so on. If now we have two cases. If an minus 1 appears many times, if it appears many times in a1, a2 up to an minus 1, this implies that an will be large. And if we say, on the other hand, if we say that if an minus 1 appears few times only few times, then an will be small. So now we will consider the case where the sequence an is bounded. Now we have three cases. First of all, consider the case where the sequence an is bounded. So when an is bounded, it arises three cases. First one is If the sequence, we consider the sequence AN is bonded for small n is greater than n, then this implies that there are only a finite number of distinct values that an can take when sequence is bonded. Another case we will study that if an is bonded then we can say eventually some values must repeat. This is understood. If an is bonded, then eventually some values repeat. Now another case that we have another case if an is bonded and for small n is greater than n, and we say that an depends upon the count of an minus 1 in the infinite prefix. So we will say that a1, a2 up to an minus 1 has potential for repeating patterns. After this, we will focus on the frequency of the values. So, we will consider the frequency. Now let consider another sequence. Let CKM be a count of the number k in the subsequence a1, a2 into am. For small n is greater than n and the an will be equal to the C of an minus 1 into n minus 1. If an becomes constant for large value or small n, then we say that if an is constant, then we say that condition is an is equal to k. K is some constant and small n is greater than capital M. So must be number of times k appeared in the preceding terms. So we will apply the pigeonhole principle for the subsequences. Now apply the pigeonhole principle to the subsequences. Then we will, according to pigeonhole, we will consider two sequence like Sn is equal to the A1, A3 on the odd, and S2 is equal to the even, A2, A4, A6 up to so on. Then since A and R positive integers, they are either unbonded or eventually bonded. So if two cases arises that if An is eventually bonded this means that small n is greater than n dash, then values of An belong to the finite set because An is eventually bonded finite set. And the other condition is that if a sequence take values from a finite set, takes values from a finite set, then the next term is determined by the frequency of the previous term. So the next term is determined by the frequency of the previous term, which implies that previous terms are in growing prefix, it is highly likely to become a eventually periodic. So we will say that the sequence is eventually periodic. Now we will prove this also by the contradiction, that consider, if you want to solve this by contradiction, assume that S1 and S2 both are not eventually periodic. This implies that both sequences contain infinitely many distinct values, and then applying this principle, final result will be contradict, and you will say that both the sequences are eventually periodic. This is an alternate method. So we will write the final conclusion that the nature of the An as a count of the previous term, and An cannot grow independently without the bond of the previous term. So sequence must enter a state where its values repeat. So cannot grow without bond to the previous term. So we will say that for large value of n, at least one of the subsequence must be eventually periodic. So this is the final result. If you found this video helpful, subscribe Math Solver 1117 and also hit the bell icon to get notification for more upcoming videos. In the next video, we will solve most important IMO questions that are to be predicted come in this exam. Best of luck for your exam. Stay tuned.